Have you ever stood on a beach, gazed out at the vast, flat horizon, and wondered why we are told we live on a giant, spinning ball? It is a question that taps into our most basic human intuition. Our senses, the very tools we use to navigate our daily lives, report a world that is stable, stationary, overwhelmingly flat. From our vantage point, the ground does not curve, the oceans do not spill off the edge. We certainly do not feel the dizzying rush of spinning through space at 1,000 miles per hour. This discrepancy is the seed from which a fascinating and persistent idea grows: the idea of a flat Earth. This is not a new concept, a logical conclusion based on direct, everyday observation. Our ancestors looked up at the dome of the sky and down at the plane of the Earth and built their worldviews accordingly. It was only through centuries of careful observation, mathematics, and the collective work of curious minds that a different picture emerged. A picture of a spherical planet, one among many, orbiting a star in the vastness of space. Yet the old idea lingers, a testament to the power of personal experience over abstract scientific consensus, and it forces us to confront a fundamental question about how we know what we know. Before we can explore the reasons behind the belief, we must first understand what the modern flat Earth model actually proposes. It is not simply the absence of a belief in a globe, it is a specific alternative cosmology. In its most common form, the model describes the Earth as a large, disc-shaped plane. The North Pole is imagined to be at the center of this disc. The continents are spread out around it. Antarctica is not a continent at the bottom of a globe, but rather a massive ice wall that encircles the entire perimeter of the known world. This ice wall, stretching for thousands of miles, is said to hold in the oceans and mark the boundary of our realm. The sky, in this view, is not the near-infinite vacuum of space, but a physical dome, often called the firmament, which covers the Earth like a giant snow globe. The sun and moon are not massive celestial bodies millions of miles away, but small, local sources of light that circle above the flat plane, much like spotlights. Their paths create the cycles of day and night as they move over different regions of the disk. The stars are also believed to be fixed to this rotating dome, or are other forms of celestial lights within our enclosed system. It is a self-contained geocentric model that places humanity, quite literally, at the center of a manageable and knowable creation. This model is a fundamental departure from the heliocentric, globe-based understanding of the cosmos that has been the bedrock of science for over 500 years. Proponents of the flat Earth theory often assert that all evidence to the contrary, photographs from space, satellite communications, and GPS technology, is part of a massive, centuries-old conspiracy. One of the most common claims made to support a flat Earth is a simple one. The horizon always rises to eye level, no matter how high you go. This myth suggests we should have to look down to see the horizon from a great height. The fact, however, is that the Earth is extraordinarily large. From an airplane at 35,000 feet, the curvature is subtle. The horizon still appears relatively flat and close to eye level. However, the drop is measurable. From the much greater heights achieved by weather balloons, rockets, the curve of the Earth becomes unmistakably visible, a beautiful and gentle arc against the blackness of space. Another popular myth is that water always finds its level, so it cannot stick to a spinning ball. This argument uses our everyday experience with water in a glass to question how oceans can conform to a curved surface. The scientific fact that counters this is gravity. Gravity is not a force that pulls down. It is a force that pulls everything toward the center of mass. For a massive spherical object like the Earth, the center of mass is its core. Therefore, down is always toward the center of the planet, which is why water forms a spherical shell around the globe. Water is indeed finding its level, on a planetary scale. A third key myth asserts that if the Earth were spinning, we would feel the motion or be thrown off. We are told the Earth rotates at over 1,000 miles per hour at the equator, a speed that seems impossible to not notice. The fact is that we do not feel it for the same reason you do not feel the speed of a car or an airplane when it is moving at a constant velocity. Everything, the ground, the atmosphere, you, the chair you are sitting on, is moving together as one system. It is only acceleration or deceleration that we feel. The Earth's spin is remarkably consistent, so we move with it, experiencing no sensation of motion, just as a passenger on a smooth flight feels perfectly still. Finally, there is the myth that you can see things that should be hidden behind the curve. Flat earthers often point to instances of seeing distant cities' landmarks that, according to curvature calculations, should be out of sight. The scientific fact here involves a phenomenon called atmospheric refraction. The Earth's atmosphere has varying layers of temperature and density, which can bend light. Under certain conditions, light from a distant object can be bent downwards around the curve of the Earth, creating a superior mirage. This makes the object appear higher than it actually is. Understanding why these beliefs persist beyond the scientific arguments into human psychology and sociology. One primary driver is deep-seated distrust of authority. Governments, media, scientific institutions' trust is eroding. Alternative theories offer empowerment. For some, flat Earth belief is a declaration of independence. Need for community and belonging drives participation. Flat Earth online forums, social media groups, conferences. In these echo chambers, dissenting opinions are dismissed as shilling. Conforming views are celebrated. Social validation builds identity and purpose. Exclusive secret knowledge can be more appealing than mainstream consensus. Brains seek patterns and simple explanations. The flat Earth model is simple and intuitive. It replaces cosmic vastness with an enclosed creation. This feels secure and controllable. General relativity, cosmic microwave background are hard to grasp. A physical dome is straightforward and reassuring. Misinformation spreads online. Algorithms push users down rabbit holes. The overwhelming scientific consensus supporting a spherical Earth is not a matter of opinion or belief. It is the result of centuries of accumulated, verifiable evidence from countless independent sources. The most direct and irrefutable evidence comes from space. Thousands of photographs, countless hours of live video footage, astronaut satellites from dozens of different countries. These images consistently show a spherical Earth rotating on its axis. Continents, oceans, weather patterns. To dismiss this would require believing in a conspiracy of unimaginable scope, flawless execution across competing nations for over 60 years. Everyday experiences also confirm around Earth. Consider air travel. Sydney, Australia, Santiago, Chile, an approximately 14-hour direct flight across the Pacific Ocean. This route only makes sense on a globe. On a flat Earth map, that trip would require flying over North America, the Atlantic, and take more than twice as long. Airlines plan routes based on a spherical planet. It is the most efficient, cost-effective way to travel. The multi-trillion-dollar global logistics and transportation industry is built on the mathematical certainty of a globe. Modern technological infrastructure depends on it. The global positioning system in your phone or car works by communicating with at least 24 satellites orbiting the Earth. Each satellite signal includes its precise location and the time. Your receiver triangulates those signals to get a position. This only works because we can precisely model satellite orbits around a spherical Earth, accounting for gravitational variations and relativistic time dilation. If the Earth were flat, GPS would be impossible. Finally, gravity is a simple, observable phenomenon. On a spherical planet, gravity pulls toward the center of mass, so down feels the same in New York, Paris, Tokyo. If the Earth were a flat disk, gravity would pull toward the disk center. The further from center, the more sideways the pull. At the disk's edge, down would feel like 45 degrees. No such effect has ever been observed or measured. Among the many stories within the flat Earth community, there are also those of people who have journeyed out of it. One of the most well-known examples is that of a man who became a prominent voice in the online community. For years, he was convinced of the flat Earth model. He created content and participated in debates. They bought a highly precise instrument, a laser ring gyroscope. During filming, the gyroscope was activated. It was detecting rotation. The reading was unmistakable, 15 degrees per hour. His story shows that genuine curiosity and honest engagement with evidence can lead anyone toward a more accurate understanding of the cosmos. The enduring debate over the shape of the Earth is more than a fringe scientific argument. It is a mirror reflecting our modern relationship with information, trust, and truth itself. The scientific method, however, remains our most reliable tool for navigating reality. Its strength lies not in claiming absolute certainty, but in its process of questioning. Testing, observing, and self-correction converge on a single, unambiguous conclusion. We live on a magnificent, rotating sphere. This is not a story told by a single authority, but a conclusion independently verified by millions of scientists, engineers, and pilots across generations and cultures. The antidote to misinformation is not censorship, but education and the encouragement of critical thinking. Ask questions. How does a lunar eclipse work on a flat Earth? Why do travelers in the southern hemisphere see different constellations? How can we video chat in real time with someone on the opposite side of the world? In the end, the cosmos invites us all to look up and wonder. That sense of awe is a shared human experience, whether you see the sky as a dome or as a window into an infinite universe. Let us channel that awe into a relentless pursuit of understanding. Check sources, test claims, and remain open to evidence, even if it challenges your cherished beliefs together, on this beautiful, round world we all call home.